Okay, so today we're going to review a little bit of solving trig equations. So remember, to solve a trig equation, we are going to be looking at the unit circle to solve for our variable that's inside of our function. So we want to figure out what, and in this case, what radian measure is going to make us have a balanced equation. So basically we would look at our unit circle and figure out where the trig function is going to be that value. So like what angle will I have that ratio? Okay, that's a terrible circle, I'm sorry. So for these questions that we're going to look at, we're going to be looking at one full rotation of the unit circle, so from 0 all the way around to 2 pi. So then we would have pi over 6 here, right? So it'd be pi over 6, pi over 4, pi over 3, pi over 2. This is terrible, I'm sorry. 2 pi over 3, 3 pi over 4, 5 pi over 6. Wish I had a, and this is a pi. Wish I had a better, then we would be at what, 7 pi over 6. Then we would be at 5 pi over 4. Then we'd be at 4 pi over 3. And then 3 pi over 2. 5 pi over 3. 7 pi over 4. 11 pi over 6. And then back to 2 pi. Okay, so remember on our unit circle, we have an x and y value that's associated with it. So for here, for this point on the unit circle, it'll be the x value of 1 and a 0. This point here would be the x value of square root of a 3 over a 2 and a 1/2. This x and y value would be square root of 2 over 2, square root of 2 over a 2. And then this would be a 1/2 and a square root of a 3 over a 2. So remember, if you can remember the first quadrant, you can look at the second, third, and fourth, just knowing your signs. So remember, your x values will be negative here, the y values will be positive. You'll have negative and negative x and y values, then you'll have positive and negative x and y values. So this would be a what, 0, 1. This would be a negative 1, 0. This one would be a 0, negative 1, and then back around. Okay. All right. So let's look at solving. So basically, you're gonna have to isolate your sine function, your cosine function, your tangent function when they're just basic like this. So if I wanted to solve this trig equation, I would isolate as much as I can. So I'm going to move the 5 sine over to the other side. So I would subtract 5 sine here. So this will become a negative 2 sine of x minus a 2 is equal to a negative 1. Here we'll add a 2. So we'll have a negative 2 sine of x is equal to a 1. Then I'm going to divide by a negative 2. So I'm going to get sine of x is going to be equal to a negative 1/2. So where is sine? So where is the sine function? And remember, cosine represents your x values. Sine is going to represent your y values. So where is sine going to be equal to a negative 1/2? So it's going to be a positive 1/2 here at pi over 6, but I'm looking for a negative, and sine is going to be negative. It's going to be a y value, so it's going to be a negative over here. So it's going to be a 7 pi over 6, and it's also going to be a negative in the fourth quadrant, so 11 pi over 6. So my solutions here are going to be 7 pi over 6 and then 11 pi over 6. Okay. All right, well, look at this one here. So this one is 2 cosine squared x plus cosine of x minus a 1 is equal to a 0. So this one I'm not going to be able to just isolate the trig function. So for this one I am going to have to factor this one. So the first one we just isolated the trig function, and so for this one I'm going to have to factor. Alright, so to factor this, if I look, I have a square term and I have a constant. So what I'm going to do is I'm going to let u be equal to cosine x here. So I'm going to do a little substitution here so it's going to be 2u squared plus a u minus a 1 is equal to a 0. Now this looks like something that you would have factored in algebra, okay? So you could definitely factor it like this. So what multiplies together to give you a negative 2 and adds together to give you a positive 1. So what multiplies together to give you a negative 2 and adds together to give you a positive 1. So it's going to be a 2 and a negative 1, right? So this would be 2u squared plus a 2u minus a 1u minus a 1. Get factor by grouping here. Factor out the 2 u's, and you'll have a u plus a 1. Factor out the minus a 1, and you'll have a u plus a 1. So that was terrible looking, sorry. So you will have a u plus a 1, and then a 2u minus a 1. But we let u be our cosine, so this is going to be cosine of x plus a 1. And you don't have to do it with that substitution, just sometimes people can see it better that way. But if you want to keep it as trig functions in there, that's completely a-okay. And then we'll set each one of these factors equal to 0, just like we would if we were solving a trinomial. So then we would find where cosine of x is going to be equal to a negative 1, and then where cosine of x is going to be equal to a 1/2. So where is cosine of x going to be equal to a negative 1? So where, let's look at our unit circle up here. So where is x going to be a negative 1? And so it's going to be negative 1 at the radian measure pi. So x is going to be equal to a pi. Where is cosine going to be equal to a 1/2? So where's your x value going to be a positive 1/2? So it's going to be a positive 1/2 here at pi over 3. Not over here because it's going to be a negative. Not over here because it's going to be a negative. But also in the fourth quadrant because it's going to be a positive here. So 5 pi over 3 and pi over 3. Okay. All right, so what about this one here? Right, so for this one, we can't factor, but I could isolate this square. So the same thing, we could let u be equal to cosine of x. So here this would be 4 u squared minus a 3 is equal to a 0. And if I isolate that u squared, I'm just doing it by the square root property. So this would be 4u squared is equal to 3. Divide both sides by 4. So you'll have a 3 over 4. And then you take the square root of both sides. So you'll have u is going to be equal to a, remember that plus and a minus, that's important. And it'll be square root of 3, and then the square root of 4 is just going to be a 2. So what you're looking for is where is cosine going to be both positive and negative, square root of a 3 over a 2. So that's everywhere, right? So it's in all 4 quadrants. So where is cosine going to be square root of a 3 over 2? So it's going to be at pi over 6. It's going to be at, because it's a negative over here, so it would be a negative square root of 3 over 2, which is okay, 5 pi over 6. It's going to be a negative square root of 3 over 2 right here at 7 pi over 6. And then it will be a positive, another positive square root of 3 over 2 over here at 11 pi over 6. So every one of those pi over 6s. So x is going to be equal to a pi over 6, 5 pi over 6, 7 pi over 6, and then again all the way around 11 pi over 6. So all 4 quadrants you have a solution. Okay, so let's look at this one here. So this one looks kind of funny, but we're still going to do this one by factoring. Sorry, I should have put factoring at that first one as well. Because I have a tangent and I have a tangent, I have the same trig function there. So to factor though, remember you have to let it be equal to 0, right? So I need to move this over here. So this is going to become tangent of x sine squared x, and then I'm going to move this over, so it's going to be a minus 3 tangent of x is equal to a 0. So to factor this, so now that it's equal to 0, I can factor this. So I can factor out a tangent of x. So if I factor that out, then I'll have a sine squared x minus a 3. And then we're going to set both of those equal to 0. So where is tangent of x equal to 0? And where is sine squared x minus a 3 equal to a 0? Okay, so where is tangent of x equal to 0? And then when I solve this one, very similar to number 3 up there, I'm going to isolate and then take the square root of both sides. So I'm going to have sine of x is going to be equal to plus and minus square root of a 3. So on my unit circle, where is tangent going to be equal to a 0? Okay, so tangent is going to be sine over cosine. So it's going to be your y values over your x values. So where is tangent going to be 0? Okay, so I should have written this on another sheet of paper to make it easier for us. So y over x. So at 0, y over x, all of these will give you something other than 0. That'll give you an undefined. And then what about here? Y over 0, so that would give you a 0 as well. So at 0 and pi, tangent will be equal to a 0. Okay. Okay, then we have the sine of x is equal to plus or minus square root of 3. So is that on the unit circle anywhere? So that does not exist. So it cannot be greater than 1 or it cannot be less than a negative 1. So this does not exist. Okay. Alright, so about this one. I've got 2 cosine squared x plus a 3 sine of x is equal to 0. Can I factor anything out here? So I can't factor. So I am going to have to use an identity. I would always try to factor if I could. So for this one, you will have to use an identity to solve. So that's really important here. Alright, so I've got a cosine squared and I have a sine. Well, the only thing I know is that I could plug in something for cosine squared. So remember, the Pythagorean identity is sine squared plus cosine squared is equal to a 1. So if I was to solve the Pythagorean identity for cosine squared, it would be 1 minus a sine squared. So for that cosine squared, I'm going to plug in that 1 minus a sine squared. And then this is going to help us. It's all in terms of sine here. So I'm going to treat this one very similar to the factoring one. So if I multiply, so I'll have 2 minus a 2 sine squared x plus a 3 sine of x. Okay, so then I'm going to put it in descending order. So it's going to be a negative 2 sine squared x plus a 3 sine x plus a 2 is equal to a 0. Just put it in your order. Squared, just regular, and then nothing, no sign. All right, I've got a negative here, so if I multiply 3 by a negative, this would be turned into 2 sine squared x minus 3 sine of x minus a 2. And I can do my factoring a little bit easier this way. All right. So if you want to do your substitution, so factor now. So now we're able to factor. So I'm going to let u equal sine. Maybe that'll help a little bit. So this will be 2u squared minus 3u minus 2 is equal to a 0. So what multiplies together to give you a negative 4 and adds together to give you a negative 3? So that's going to be a what? Negative 4 and a positive 1. Right? So this is going to be 2u squared minus 4u plus a 1u minus a 2. So factor out a 2u, and you'll be left with u minus a 2, u minus a 2. So you should be good where you don't have to do all of this by grouping. You should be real good about factoring. All right, what did we let u be? So I'm going to change the u into sine of x. And then now that it's equal to 0, I'm going to set both of those equal to 0. So I'm going to have sine of x minus a 2, 2 sine of x plus 1. So sine of x is equal to a 2. Can that happen? So remember what we said earlier, that sine of x cannot exceed 1 and negative 1 there. So it's bounded in between there. So that's going to be no solution there. And then if we solve sine of x, it would be equal to a negative 1/2. So where is sine of x equal to a negative 1/2? So it's going to be the y value. So where's your y value going to be negative? It's going to be in the third and the fourth quadrant. So it's going to be a 1/2. So it's going to be the pi over 6. So it's going to be 7 pi over 6. And it's going to be an 11 pi over 6. So x here is going to be equal to 7 pi over 6 and 11 pi over 6. Good deal. All right. If you have any questions about solving trig equations, let me know. Y'all have a great day.